Okay. Hopefully yesterday's maths lesson made sense and wasn't too tricky. I think I said it yesterday. I can't remember if I didn't. Fractions, it's one of those things. It's not really complicated, but it is something that's really easy to get muddled in. So the knowledge I'm asking you to learn isn't really complex and tricky to learn, but it does require your concentration and focus, because it's something that you can easily just not pay attention for a split second, and then the next bit won't make sense. So if yesterday's lesson didn't make sense, please don't just think, oh, I'm just going to carry on. It doesn't matter. It does matter. Go back, rewatch the video, do some of the tasks. We're not in school at the moment. I can't be walking around and checking if you've got it. I'm relying on you to be responsible for your own learning. So it's really important. Fractions are something that you've already been using for your whole life, but you're going to continue to use them for the rest of your life. You don't want to not understand it now. So please, if it hasn't made sense so far, go back and watch the videos again. If it's still not making sense, ask your parents to send me a message, and then we can work out what's not making sense and we can fix it. I don't want anybody just sitting here going, I haven't got a clue what's going on, but I'm just going to carry on watching the video as if it was an episode of EastEnders. Okay, it's really important. If it's not making sense, you've got to take action. Okay, enough of that. Moving on. We're going to carry on with ordering and comparing fractions today. So we've got a question here. What colour is that? Yellow. So a yellow-shirted friend said, each roll is cut into 6 equal pieces, and I take 7 of those pieces. Orange shirt says, each roll is cut into 9 equal pieces, and I take 10. Who has taken more? So they both got 2, it looks like Swiss rolls there. 2 Swiss rolls. Yellow shirts cut his into 6 equal pieces. Each roll has been cut into 1, 2, 3, 4, 5, 6 equal pieces. Orange shirt has cut her 2 rolls into 9 pieces. Sorry, yeah, 9 pieces. She's taken 10. He's taken 7. Who has more? If you want to pause the video and have a think about it, draw it out, fantastic. Well, if we start to think about this, 6 pieces and he's taken 7, that means he's taken 1 whole roll and 1/6. 9 pieces and she's taken 10 means she's taken 1 whole roll and 1/9. So we know they've both had 1 whole Swiss roll, but they've also had 1/6 and 1/9. We could look at it as our improper fractions, but sometimes it's easier, as I say, to deal with mixed. We've got a whole, 1/6, 1/9. And actually, just by looking at this, you might start to get a sense of what is greater, a 1/6 or a 9. This is where people often get really confused in fractions. We're so used to thinking that the larger the number, the larger the number, the bigger the piece. But of course, in fractions, when we're talking about the denominator, the larger the number, the smaller the piece. To get that into your mind, sometimes it's helpful to think about pizza. If you have a pizza for lunch and someone cuts it into 2 pieces, so you each have half of a pizza, that's massive. If you have a pizza for lunch and someone cuts it into 100 pieces, it's not so massive, is it? It's quite a small piece of pizza, 1/100th of a pizza. So the larger the denominator, the more parts we've made that whole, the smaller the part will be. So a 9th is smaller than a 6th. And here we can see 6, 1, 2, 3, 4, 5, 6. And here we can see 9ths, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that the person who took more was yellow shirt, because he had 1 whole and a 6th, whereas orange shirt had 1 whole and a 9th. Right, let's have another try. So which is less? This time we're talking less, not greater. Which is less, 7/6, pardon me, or 5/3? Which is less, 7/6 or 5/3? Pause the video for a second and have a little think. Brilliant. So, very similar, 7/6, 5/3. They're both improper fractions. We know that we're dealing with more than one. 7/6 is 1 and 1/6. 1 whole, sorry, and 1/6. 5/3 is 1 whole and 2/3. Notice by drawing it out like this, and I could have ignored the 1 if I wanted to, and just dealt with my 6ths and 3rds. But drawing it out, it makes it really obvious which is less. I know we always say this, and you always ignore me. When we draw things out, it does make it easier. It doesn't. I know it sometimes feels like you're being more babyish, but it makes maths simpler. The most complicated mathematicians and scientists draw things out. Why do you think architects draw models of houses? Because drawing it makes a complicated thing simpler. So don't be afraid when we're talking about fractions to get a bit of paper out and draw a rectangle and split it into parts. It will make fractions clearer in your mind. Right, so which is less, 7/6, 5/3? We know that 5/3 is more. We've seen that in this diagram. There was another way we might have solved this though. We might have taken our 5/3, there's our whole, and there's our 2/3. And we might have said, you know what, I'm going to split each of these thirds in half. If I split each of these thirds in half, then look what suddenly happens. 1, 2, 3, 4, 5, 6. So by splitting those thirds in half, I can now see the equivalent is 6. That whole is in 6 parts. Over here, my whole is in 6 parts. But if I do that for those funny 2/3 here, I start to see what my equivalent to, where's my fraction gone? 5/3 is in 6. Oh, there it is. So 5/3 becomes 10/6. So if you notice, each of those thirds I've cut in half. I've doubled the amount of parts. So I've doubled my 3 to get to 6 because each of those thirds I've made 2 parts. And if I've done that with my denominator, I must do that in my numerator. So I've doubled 5 and got 10. So now I can see that I've got 7/6 or 10/6. Oh, here it is. So I can see which is smaller and which is greater. Right. I know this is a bit blurry, sorry. I'd like you to pause the video and see if you can arrange 11/8, 5/4, and 3 halves from smallest to greatest. So pause the video now and give it a try. Excellent. So you might have started by drawing it out like this. I've got my 11/8, which I've realized is 1 whole and 3/8. I've got my 5/4, which is 1 whole and 1/4, or 1/4, we might say. And I've got my 3 halves, which is 1 whole and a half. Let's get this out. So you might have just drawn it, seen the shape sizes, and put it in order, or you might have started to do some conversions. I know that my whole is split into 4. But again, if I cut each of these in half, I'm doubling the amount. I'm getting instead of my whole split into 4, I can make it split into 8. So by doubling 4, I can make 8. I double my 5 and I get 10. So I can see that this is actually 10/8. In fact, let's just close this and we can actually do it. They're not going to be exactly half because my computer's not going to be nice to me, but imagine I'm cutting these all beautifully in half. There we go. then we would see that I've got now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 eighths. Likewise with this was cut into 2 pieces. But if I cut each of these into 4, if I make each of my parts into 4 parts, obviously they would be equal if it wasn't for the fact that my computer doesn't like me. Then now I've got 8 parts. So I've made each of my 2 parts, I've times it by 4. I've made each of those parts 4 times as many. 2 times 4 is 8. 3 times 4 is 12. I've now got 12 eighths. So I can draw it out and just look at the size of my eyes and try and kind of estimate, guess. But also I can draw it out and then start cutting my parts up to make them the same size. So I can do a real like-for-like comparison. And I can see, right, I've got 10 eighths, 11 eighths, and 12 eighths. And the trick to this is remembering that 12 eighths was 3 halves, 11 eighths was 11 eighths, and 10 eighths was 5 quarters. It's important at this point to remember that this isn't always the most efficient strategy. This works when the numbers are useful. It's not always brilliantly useful at this stage. So sometimes at this point in year 5, you might want to just draw them out. And at some point you'll see really clear patterns. So when I'm dealing with even numbers like this, it's really simple to turn fourths into eighths or halves into eighths. It would be less simple to turn thirds into eighths. And there is a way we would do that, but we will look at that later on. We're not going to talk about that today. Okay, let's have a try together now. So, which is greater, 3/4 or 4/3? Which is greater, 3/4 or 4/3? I'm going to get you to pause this video and just have a think about it for a moment. If you want to draw something great, you don't need to. Just have a think. Brilliant. So, the reason we know that 4/3 is greater is because we can, and this is really small. Ooh, there we go. Because I can, before I start thinking, oh gosh, this is thirds and this is quarters, and Mr. Turnham just said it gets a bit tricky when you're dealing with thirds and quarters and halves and eighths. But actually, we know something about 4/3. We know that's an improper fraction. 3/4 isn't an improper fraction. It's a proper fraction. It's less than a whole. 4/3 is more than a whole. In fact, 4/3, if we wrote it as a mixed fraction, is 1 1/3. Well, if I know that 4/3 is greater than a whole, and 3/4 is less than a whole, then without having to do too much maths, I've solved my question. I haven't had to convert 4/3 into an equivalent fraction with 4 as the denominator. I've just seen that's more than a whole, that's less than a whole. That means 4/3 is greater. So there are lots of shortcuts with fractions, but you've just got to look. What does that actually tell me? What is 4/3 actually saying? It looks confusing, but actually, if I look at it as 1 1/3, less confusing. Which is smaller, 5/12 or 1/4? Pause the video and have a little think. Well, before I reveal the rest of my screen, are either of them improper fractions? Hopefully you're all shouting out, no, they're not. No, both of them are proper fractions. The numerator is smaller, less than the denominator. Oh, what have I done there? But we can start to, let's move this out of the way so you can see what I originally had. I know that I've got my quarters, and here I've got my 12ths. And I can start to think about something here. I can start to think about what would happen if I wanted to split. Whoop. I can try and do this neatly. My fractions. Would that help? Are those equal parts? Are there always 3 of these in every one of these? Well, let's have a look. Let's just check. There are 3 in there. There are 3 in there. And there are 3 in there. So I know that I can split each of my quarters, into 3, and it will be the same as 12ths. So let's just quickly, I know I've got 1/4 and I've got 5/12. I can see which one's bigger, but I can also, by bringing this over, I can now see that's 3/12, 4/12, 5/12. So there's 5/12. It's definitely less than here. I could have also said that 1/4 is actually the same as 3/12. Hopefully that hasn't confused you. If it has, don't worry too much. I've just kind of jumped ahead a little bit there. The important thing is that we can see, get rid of all of that, that quarters are bigger than 12ths. Hopefully we can see that 1/4 is the same as 3/12. Well, if 1/4 is the same as 3/12, we can then see what 5/12 is, and we can see that that is larger than 1/4. So which is smaller is 1/4. Oh, let's just jump back to full screen. There we go. Oh, it's gone blurry again. Arrange the numbers from smallest to greatest. So pause your video here, have a little think. Brilliant. So are these proper or improper fractions? Brilliant. Hopefully lots of you are shouting out, we've got an improper, and a proper. So that tells us something about the order of these fractions already. And actually we can start to think about this. So I know that 11/4 is actually the same as 2 3/4. That's 1, 2, 3, 4. That's 1. 1, 2, 3, 4. That's 2. 1, 2, 3, 11, 2 3/4. I know that 17/8 is the same as 2 1/8. I know that because I've drawn out my bar of eighths and I've coloured in 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You might have also known your 8 times table. 1/8 is 8, 2/8 is 16. Oh, that's 2. And I've got 1 left over because I had 17, not 16. Doesn't matter how you work that out, but we've seen that 17/8 is the same as 2 1/8. 11/4 is the same as 2 3/4. And we've seen that 2/3 we knew was less than a whole. So I can start to see how I would order this. Now they wanted smallest to greatest. Well, I know without doubt that my less than a whole is going to be smallest. I know both of these had 2 wholes. So now I'm just thinking about this one that's part. Here I've got 3/4. Here I've got 1/8. I knew eighths are smaller and there's only 1 of them. I knew quarters are bigger and I've got 3 of them. So that's got to be my biggest. And I can see, in fact, it's my biggest, which plonks that firmly in the middle. Okay, so sometimes you've got to think about what you know about the fractions. Have a try with this one. This time we're going greatest to smallest. Pause the video, have a go. Right, so 5/3, is that proper or improper? 7/4, proper, improper? 13/12, proper or improper? Brilliant. They're all proper fractions. We know in all of those, we've got one whole. So we're now just looking at the parts. We've got thirds, quarters, and twelfths. Well, if we had 1/4, 1/3, 1/12, we know which would be the biggest and smallest. But it's not that clear cut. We've got 2/3, 3/4, 1/12. I know my 1/12, 12ths are the smallest, and there's only one of them. Ooh. So that's definitely going to be my smallest. So let's plonk that over in the smallest because we're going greatest to smallest. So then I've got to think about my 2/3 and my 3/4. And when you're looking at it, it starts to get a little bit tricky, doesn't it? But I think you can see that the thirds, which are bigger parts, is less. Sorry. We're talking about the 2 bits. So the 2/3 is greater than the 3/4. So we're going to put, what we're doing. Go. I don't know if you noticed, I just found myself confused there because I started thinking about the green section as opposed to the yellow section, which is what our numerator is telling us about. So it's really important that we're remembering of our yellows, which is greatest. So that is greater than that, which is greater than that. Does that make sense? Hopefully it does. And we could use our correct symbols to show us that. Can I do that? Let's see. No. Oh, what's it doing there? Pop my symbols in if I wanted to as well, with my point to the smallest one eating up the larger one. Okay, let's not do that. You didn't see that, nothing there to see. What I'd like you to do is try the 2 worksheets. The PDFs are on, sorry, the link to the files are on the PDF from today's class story. I'd like to give those 2 worksheets a try. Once you've done that, come back to the video and check your answers. Hopefully you have paused and doing the sheets now. You're not waiting for the answers to come up to cheat. Brilliant. I'm going to assume you've all done the sheet. So here are the answers to worksheet 5, question 1A and B. Question 2 and question 3. And question 4. And I will see you tomorrow to carry on the rest of fractions.